Hi, welcome back to Music Chemistry. This is Stoichiometry Limited and Excessive Reaction Lesson 2. Okay, let's look at the first problem. What is the mass of Al2O3 produced from 10 grams of Al and 10 grams of O2? Well, there's our balanced equation, and now we need to figure out what the mass of Al2O3 is. To do that, we have to also understand which ones are limited and which ones are excessive reactant. Okay? So what we're going to do is we're going to go ahead and take what we know. We have 10 grams of Al, so it's going to start with this one, times 1 mole of Al divided by our molar mass, which is 27.0 grams of Al, okay, times our mole ratio. We have 4 moles of Al and 2 moles of Al2O3, and then we wonder how many grams it's going to make. So 1 mole of Al2O3 on top, and the molar mass of Al2O3 is 102 grams. And I did that by figuring out its formula mass. Okay, so this cancels this, that cancels that. See how that goes? Pretty darn snarly, huh? And when we do that, we get this to make 18.88 grams of aluminum oxide. All right, so let's try the other one. So look at the other reactant, 10 grams of O2. Okay. Let's react with 1 mole of O2 on the top, 32 grams of O2 on the bottom, and the ratio between oxygen and aluminum oxide. Okay, so let's go and get that. So we have 3 moles of O2 on the bottom, and 2 moles of Al2O3 on top. And then we'll set this up again. 1 mole of Al2O3 with 102.0 grams of Al2O3. And when we do that, we're going to cancel out these units here. And this made 21.25 grams of Al2O3. Well, the correct answer is going to be this one right here. And the reason why is our aluminum is going to be our limiting reactant. So our limiting reactant maxes what we can make. Excessive reactant always has stuff left over, so we don't use it to calculate what our percentage of yield. All right, let's look at the next question. All right, so we have the black oxide of iron 3O4 in nature as the mineral magnetite. This substance can also be made in the laboratory by a reaction between red hot iron and steam according to the equation. 3Fe plus 4H2O yields Fe3O4 plus 4H2. All right, when 36 grams of H2O is mixed with 167 grams of iron, which is the limiting reactant? Okay, dokie. Well, let's do that. So we're going to take 36 grams of H2O, turn it to moles of H2O, of course, over 18.02 grams of H2O, and this is going to give me approximately 2 moles of H2O. On the other hand, we're going to take the 167 grams of iron, okay, times 1 mole of iron, And let's see here, divided by 55.85 grams of iron. And that is going to give me approximately 3 moles of iron. So what we're going to do is, this is what we have for H2O. And then we're going to figure out what we need by taking the moles of iron. This is a different way of doing things. Divided by the moles of iron. So we're going to need 4 moles of H2O. This is what we need. This is what we have. So therefore, our H2O is our limited reactant. That makes our iron the excessive reactant. And that's it for this lesson, guys. Listen, you be snarly, and we'll see you back here at Mucine Chemistry.